Hello friends, welcome to Tech Tool. In this video we will solve this problem. So this is a problem on Turing machine where we are given a Turing machine M and we have to find out the language that will be accepted by this machine M. Fine. So here I assume that you are familiar with this notation. Let me write down it again. The notation is something as x, comma x, comma x. Here the first one represents the input symbol you are reading and the second one represents your updated symbol. That means whether you have made any changes on this input symbol or not, and the third one represents your movement, whether you will move to the left or to the right. If it is written somewhere that 0 comma 0 comma L or 0 comma 1 comma L, this means you are at 0, you will leave it at 0 and you will move in the left direction. And this means you are at 0, you will change it to 1 and you will move to the left direction. So I hope you understood this notation. So this notation is used in this problem. So the Turing machine is having three states. One is your final state and we have some transitions given between these states. So we will take every language one by one and we will check whether that language will be accepted by this machine or not. So let me take the first language. Fine. If we will take the first language, your language is L, 0 to the power n and 1 to the power n, where n is greater than equals to 1. That means the sequence of 0 followed by the sequence of 1s. Fine. So let me take a simple string and we will check whether that string will be accepted by this machine or not. The value of n should be greater than or equals to 1. So I am taking here the value of n as 2. So our string will be 0, 0, then 1 and 1. The rest of the entries will be blank entries. Fine. So now we will check whether this string will be accepted by this machine or not. You are in Q0 and you are at symbol 0. So basically you are here. Okay, you are in Q0, you are watching symbol 0. So what will you do now? You will leave this symbol at 0 and you will move to the right direction. You will leave this at 0 and you will move to the right direction, means you are here and the state is now your Q1. Fine. Now you are in state Q1 and the symbol is 0. So if you are in state Q1 and the input symbol is 0, you will again leave it as 0 and you will move to the right direction. So you will leave this symbol as 0 and you will move to the right direction. So means you will be now at 1. So you are in state Q1 and the symbol is 1. So if you are in state Q1 and the symbol is 1, you will leave it as 1 and you will move in the left direction. That means you will leave it as 1 and you will move to the left direction. Means you are again here. Fine. Now here you are in state Q0 and the symbol is 0. So if you are in state Q0 and the symbol is 0, you will leave that symbol at 0 and you will move to the right direction. So you will leave this symbol as 0 and you will move to the right direction. Now you are here. That means you are in state Q1 and the input symbol is 1. So if you are in state Q1 and the input symbol is 1, you will leave it as 1 and you will move to the left direction. That means you are now in state Q0 and the input symbol is 0. So you can see that this will continue forever. Okay, whenever you will be at this 0, you will move to this 1 and whenever you will be at 1, you will move to the left direction. That means again to the 0. So this is causing infinite loop here. So you can see that you will never reach to the final state. You will fall into infinite loop. Fine. So this will not be accepted by this Turing machine. Fine. Now we will take next language and we will take a string of this language and we will check whether this will be accepted or not. So you may notice that this language also contains something as 0 to power n and 1 to the power n. That means this will fall in the infinite loop also. Okay, let me take a string here. Let's take 0 1 0. Let's take a simple string 0 1 0 of this language. So you know that at this point, when the first change of the input will occur, that means the input will change from 0 to 1, then you will fall in the infinite loop as we have seen in our earlier language. Fine. At this point, you will be in state Q0 and you will move to the right and you will enter in state Q1. Here, you will be in state Q1 and you will leave it as 1 and you will again move to the state Q0. That means you will keep on moving left and right and you will fall in the infinite loop. That means this language will also not be accepted by this machine. Okay, this will also cause an infinite loop in the machine. Fine. Now, so our third language is 0 0 to the power n, where n is greater than equals to 0. Okay, so let's take a simple string of this language. Let's take 0 and let's take value of n as 2. So this will become your 0 0. Fine. So let's take this simple string and we will check whether this will be accepted by this machine or not. Initially you will be in a state q naught and the input symbol is 0. So you will be in a state q naught and the input symbol is 0. So you will leave it as 0 and you will move to the right direction. So you will leave it as 0 and you will move to the right direction. Now you are at q1 and your symbol is 0. You are at q1 and your input symbol is 0. So you will leave it as 0 and you will move to the right direction and you will remain in the same state. So you will move to the right direction, you will move here and you will again be in q1. Now our symbol is 0 and we are in state q1. Here also you will leave it as 0 and you will move to the right direction. Now you will leave it as 0 and you will move it to the right direction. Means now you are at blank entry. So whenever you will see a blank entry, you will leave it as blank and you will move to the right direction. Means you will be now here and the state will be your final state. That means the string will be accepted. So you can see that if you have to prove that any language will not be accepted by this machine, then you have to take any string of that language and you will prove that if that string of the language is not accepted by the machine, then the entire language will also not be accepted by that machine. So this case is for our language A and language B. But in this language, if you want to prove that a particular language will be accepted, then you have to prove it for all these strings. Fine. If all the string of that language will be accepted by the machine, then only you can say that that language will be accepted. Here you can see that it will need at least one zero. So here on 0 you will leave it at 0 and you will move to the right direction. That means you will read a 0 always. Now you can read any number of 0. You can see here at q1 you are in loop on input symbol 0. You will read any number of 0, you will leave those as 0 and you will keep on moving to the right direction. That means you will read all the zeros and then you will get a blank entry and that means you will accept the string. So you can say that this language C will be accepted by this machine. Fine. So hope you understood this problem. Please subscribe to our channel. Thank you for watching.